Hi, this is Mr. Lemansky. This is section 2.3, subtracting real numbers. This is going to be a short video. I think you'll be happy with that. This section is basically a blatant review of things that you should have been taught in 8th grade regarding subtracting positive and negative numbers. So if my short video doesn't encompass enough for you, or you need more than this, I would again suggest going to the Khan Academy site. I made that recommendation a couple videos ago, and they have a lot of, or Sal has a lot of examples, or more in depth if you feel like you need to be retrained in this from square one. All right, so to start up here, let's talk about subtracting real numbers and what we can do when this happens. There's a rule that you can always follow when you're subtracting, and it's the following. To subtract a number b from a, all you have to do is add the opposite of b to a. So if I write that out in variables, that would be like saying a minus b is the equivalent or equal to a plus the opposite of b. Now the obvious question I always get from people is, well, why would I ever want to do that? Like for something simple like 5 minus 3, we know the answer is 2. Why would I want to do that to 5 minus 3? Well, for 5 minus 3, you probably wouldn't. That's pretty simple. We've done that since grade school. 5 minus 3 is 2. But just to show you that this works, when you think of 5 minus 3, if you follow this rule, if you change it to 5 plus negative 3, you do indeed get 2. So again, the question is, why would I ever want to do that? Okay, well, it's for problems like this, where now I'm going to throw a bunch of negatives at you, like negative 19 minus negative 25. Well, it's a whole lot easier for me to just quickly change this by adding the opposite into negative 19 plus 25, and that's an easy addition. Negative 19 plus 25 is 6. Or here would be a second example of that, like negative 15 minus 27. I could easily change that to negative 15 plus negative 27, and negative 15 plus negative 27 is easy. 15 plus 27 is 42, and it's negative 42. All right, so that's the rule for subtraction. You can simply add the opposite of that subtraction, and it will give you the same answer as trying to subtract. That way, when we're working with negatives, we don't have to try to figure out how to subtract negative numbers. We can just change it into a simple addition, and that's something we've already learned how to do. I guess another quick thing to remind you of is there's a term here on page 81 that you'll see in many of the story problems in this section. That's the word change. And when you hear change mathematically, that's asking for you to subtract. You'll see an example of that on page 81. Example 3, it says evaluate change, and it's a temperature problem. And you look at the work within the problem, it's a subtraction. Or when you go to the bottom of page 81, you see a sample problem. It says car values. And the question is, what is the change in the value of the car? Change, again, is telling you to subtract. I'm going to do a few questions with you together just to make sure we're getting this. If you go to number 6 on page 82, the problem is negative 15 minus 29. And by the way, when we do these, I'm not letting you use a calculator, so this is a property you should learn if you have not already. Negative 15 minus 29. Well, I'm not actually going to do that. I'm going to change this to negative 15 plus negative 29. Well, 15 plus 29 is 44, and I know it's negative 44. Or question 8, 14.7 minus negative 2.3. I'm not actually going to do that. I'm going to change it to addition. I'm going to do 14.7 plus 2.3. Well, that's easy. That's 14 plus 2 is 16, and 0.7 plus 0.3 is 1. That's 17. Or in 14, negative 7 tenths minus negative 2 fifths. Well, I'm not actually going to do that. I'm going to do negative 7 tenths plus 2 fifths. Well, of course, I got to get a common denominator before I try adding. So remember, to get a common denominator, that's simple. I know that 5 times 2 is 10. I can get a common denominator of 10 as long as I multiply down here by 2, but that means I got to go up here and do the same, which would give me negative 7 tenths plus, this would now be 4 tenths, and negative 7 plus 4 is negative 3. That's negative 3 tenths. And then one last example I'm going to do with you is number 20. They ask us to evaluate an expression. Well, we've evaluated expressions many times now already over the first month of school, and evaluate means get the answer basically, and they tell me that x is 7.1 and y is negative 2.5. So you can see that I substituted in 7.1 for x and negative 2.5 for y. Well, then the next step, I'm going to work in parentheses. Well, I'm not going to subtract. I'm going to add the opposite. I'll do negative 2.5 plus negative 13. That's negative 15.5. So now I have 7.1 minus negative 15.5. I'm not actually going to subtract here either. I'm going to add the opposite. Well, that's easy enough. 7 plus 15 is 22. 0.1 plus 0.5 is 0.6. That's 22.6. So I think that's a good summary of what you need to do. Remember, when they ask you for change, or they're asking you to find the change, in these cases, in these problems, these are subtractions.